Welcome back. This is the second free response question from the 2016 AP Microeconomics test. I did the first one a little earlier. This again is the type of test you might see, question you might see on our next test. It might also you might find it handy when you are reviewing for the final AP test in the spring. So, here we go. Martha has a fixed budget of $20 and she spends all of it on two goods, X and Y. The price of X is $4 per unit and the price of Y is $2 per unit. The table below shows the total benefit measured in dollars that Martha receives from the consumption of each good. So, part A. I think I can actually start answering these right below here. So, part A, what is Martha's marginal benefit of the fifth unit of good X? Well, going from 4 to 5, her total benefit goes from 40 to 41, so her marginal benefit is, oops, let's write that a little bit more standard, $1. And it just says state, so I don't think I need to explain. Let's see, calculate the total consumer surplus if Martha consumes 5 units of X. Alright, well, if she consumes 5 units of X, her total benefit is $41. And then her total cost, 5 units of X, forgot how much do X cost. X are $4 per unit, so her total cost of 5 times 4 is $20. So again, this was the total benefit, and this is the total cost. Total benefit minus total cost is going to equal, let me erase that from my actual answer. Total benefit minus total cost is $21. That would be her total consumer surplus there. Ironically, that is not actually maximizing her surplus, but they don't ask about that, so let's move on. Part C. Part C says, what Martha is currently consuming 4 units of X and 2 units of Y. Use marginal analysis to explain why this combination is not optimal for Martha. Alright, well, let's see, she's doing 4 units of X. So the marginal benefit she got on that 4th unit was $4. And she's doing 2 units of Y. Her marginal benefit on that was $8. So how much did she benefit per dollar on that 4th unit of X? Because we kind of want to, just to say that, well, the marginal benefit was greater here than for Y than it was for X, doesn't necessarily tell us the whole story, because we also need to know how much we're spending on that. In layman's terms, the marginal benefit I would get from a brand new car is pretty high, but so is the price. Whereas the benefit I would get from a brand new pair of socks is really low, but so is the price. And so what we really want to look at is what is the marginal benefit per dollar that we're spending. So again, the formula is pretty simple. It's marginal benefit over the price is what we want to compare. And we want to compare the marginal benefit of X over the price of X compared to the marginal benefit of Y over the price of Y. So let's do that a second. And the marginal benefit of X over the price of X, we said the marginal benefit there was $4 for that 4th unit, and the price for of X, I believe, was $4 as well. Let me quick double check that. Price of X is $4, yes. So that equals $1. The marginal benefit of Y so I should write 1, over the price of y, so how much benefit do we get per dollar that we're spending. The marginal benefit was $8. Price of y was only $2 equals $4. Well, if the marginal benefit of y per dollar is a lot greater than the marginal benefit of x per dollar, we really should be buying more y and less x, because I'm getting more value per dollar on y's right now. So again, the question asked, use marginal analysis to explain why the combination is not ideal. Well, I would say that the marginal benefit of x over the price of x is much less than the marginal benefit of y over the price of y. I think that would be sufficient for the AP board. Might not be a bad idea to put a little description of what that is, but anyway, wouldn't be bad to show you a work calculating that as well. Part D. What is Martha's optimal combination of goods X and Y? I can think of a couple different ways to solve this. One way would be to look at do marginal analysis on each of these. So, the marginal benefit of the third good was $8. Marginal good of the second good of X was 12, and the marginal good of that first benefit of that first one was $16. And I could do the same for Y, right? The marginal benefit here was $10 for the first good, 8 for the second. Marginal benefit was only 6, so we have diminishing marginal utility here, and $4 and $2. And we could then compare the marginal benefit divided by price. So I'm just going to kind of jot these things in here. 16 divided by 4 equals 4. 12 divided by 4 equals 3. 8 over 4 is 2. 4 over 4 is 1. And then 1 over 4 is 0.25. Probably shouldn't buy that fifth one because the marginal benefit is less than what you're paying for it. But anyway, over here it'd be 10 over 2 because the price is only 2, so the marginal benefit for $1 is 5. 8 over 2 equals 4. 6 over 2 equals 3. 4 over 2 equals 2, and 2 over 2 equals 1, and we probably wouldn't buy anything more than 5 because we're probably going to have a marginal utility of less than $2 for the next one. So, what's our optimal combination? Well, it's probably where our marginal benefit per dollar equals our other marginal benefit per dollar, and if we also have to make sure that that's a combination that we can actually buy. 3 goods of X would cost 3 times 4 is $12, which would leave us $8 to buy 4 goods of Y at $2 a piece. So that is a possible combination, and that is where those two are matching. So that's one way I could potentially solve the problem. The other possible way of solving the problem would be looking at other combinations of goods and what's their total benefit. And if I do that 3 goods of X, my total benefit there is, oops, let me grab my pen, $36, and my total benefit here is 28. 36 plus 28, last I checked, that equals 64. And what are other possible combinations I could buy? Well, if I bought 4 units, if I bought 4 units of X, I'd get a total benefit of $40, but that would cost me $16, which means I'd only have 4 left because my fixed budget is $20. And so I'd only be able to buy then 2, and 40 plus 18 is only $58. And so this is a higher total benefit combination of X and Y that I can get. So what is the optimal, part D, what is the optimal combination? Martha should buy, what did we say there, 3X and 4Y. I should probably say 4 units of Y and 3 units of X, but that gets across the message there. So then part E. Part E, indicate whether each of the following will cause the optimal quantity of good Y to increase, decrease, or stay the same. I'll have to jump down on the new page here. And this is in 3 parts. So 1, 2, 3. Alright. If the price of good Y doubles, is that going to change what my optimal quantity was? Before I was buying 4 of them, 3 and 4. If the price of Y doubles, well, then this marginal benefit per dollar is no longer the same. That goes, essentially gets cut in half. And so my marginal benefit here would be 4 divided by 4 equals 1, and here it would be 1.5, and here it would be only 2. And so it looks like I would probably want to buy fewer goods Y. In fact, I think I would want to buy again where those two numbers are the same, because then I'd be spending $12 on X and I'd be spending $8 on Y. That's my optimal quantity if the price changes. So part 1, this would be my optimal quantity. Sorry for all the chicken scratch on here, but it's kind of how I think through the problem. I hope that makes sense, though. You know, the marginal benefit per dollar is shrinking when that price increases, so I'm going to decrease the amount of Y that I would want to buy. So optimal quantity of Y would decrease. And that's just kind of practical too. I mean, if you just think about it and you had no idea how to do the marginal analysis, which would make me sad, hopefully it'd be intuitive that if the price of Y doubles, the optimal amount is probably going to decrease. We're probably not going to want to buy as much. It's kind of the law of demand, isn't it? Secondly, if Martha's income falls to $10 with no changes in price, well, the marginal benefit per dollar is going to stay the same as it was before, so we can really use this column of data, but we don't have as much money. So if I bought 3X, well, I couldn't even afford 3X, because that's $12 and she only has 10. So I'm probably going to need a smaller quantity of X, but I'm also probably going to need a smaller quantity of Y. If I'm buying, say, 1X, it's going to cost me $4. That leaves me $6 left. So this is part 2 here. If I bought 1, then I'd probably want to buy, oh, what would that leave me with? I could buy up to 3 of these, which the marginal benefit of those is $3 each, so that's probably where my combination is going to be. Either that, or I would buy 2X. I don't even really need to figure this out, and if I bought 2X, I'd only have 1 Y left that I could buy. And so, bottom line, I'm either going to be buying 3 or 1 Y at this point. I'm not going to be buying as much, which again, intuitively should make sense. If my income falls, I'm probably going to want to buy less of it, unless it's a inferior good. So optimal quantity of Y would decrease. Alright, and part 3, our last one. If Martha's income doubles and the price of both goods also double. Oh boy. I'm going to have to do a little erasing here so we can actually think this through. Her income doubled, so she's got a lot more money she could spend. So she could theoretically be buying now a ton of X and Y. But we probably want to think about, again, what is the marginal benefit. Before she was buying, let's see, before she was buying 3 and 4. Well, now that her income is higher, she could buy more of them, and of course if she did buy more of them, she could increase her total benefit. However, her marginal benefit hasn't changed. Her marginal benefit from going of 3x to 4x is still $4, and her marginal benefit from going from 3 to 4 or 4 to 5, the marginal benefit here was $4, and the marginal benefit for that 5th one is only $2. Sorry, I should draw in the same here. So marginal benefit actually hasn't changed. Now, would she actually want to buy more? She could afford more. Could she actually afford more? I guess she couldn't because the prices also doubled. But most importantly, the marginal benefit hasn't changed. And would she want to purchase a 5th unit of Y? Well, the marginal benefit's $2 and the price of Y is now $4. So why would you spend $4 to gain only $2 of benefit? The answer is you wouldn't. Would you still be able to buy 3 and 4? Absolutely. And the only thing that would change is that the marginal benefit per dollar now is only 1 for that 3rd unit and that 3rd unit of X and that 4th unit of Y. So what would happen? The optimal quantity would stay the same. Stay the same. I think that's all I've got for you. I hope this video didn't confuse you more. I hope it made a little bit of sense. If you've got any questions, of course, shoot me an email or leave something in the comments section and I'll try to get back to you.